Greetings everyone and welcome in this webinar. Today we will be discussing about the basics of laboratory management systems with ISO 17025. My name is Tim Rama, the PCB organizer of this webinar, and today the guest for today will be Mr. Dotun Bolade, a specialist in the laboratory management systems. Please write your questions and comments in the question box in the right-hand control panel, and together with Dotun we will answer to them accordingly. Please, Mr. Bolade, you may continue the presentation. Thank you.
Hello, everyone. It's a very cool morning here in Nigeria. Welcome to this webinar. My name is Dotun Bolade. I'm a chemist and a laboratory professional. And this morning we'll be discussing very briefly understanding the basics of laboratory management system with ISO IEC 17025 2005. All right, to the contents, we'll look at the history of ISO 17025, some important terminology, mutual recognition agreements, good laboratory practice. We need to understand the difference between conformance and compliance. And there are some terms that are usually confused, and so it's important that we know what terms to use as professionals. And what is the relationship between ISO 17025 and 9001? There is a sort of marriage between both standards, and they're actually closely linked. And the structure of ISO 17025 that would take us into both the management requirements and the technical requirements. We are going to look at process approach, which we also call PDCA. We'll look at laboratory management system. What is a laboratory management system? What are the basic components of a laboratory management system? We're going to look at how to implement the laboratory management system, including documentation requirements. Actually, there are many requirements. Documentation is just one of the many requirements to implement a solid LMS. Technical requirements, like I said earlier, the laboratory management system comprises basically the management requirements and the technical requirements. So we are going to look at technical requirements, and then there was a slide that shows an implementation plan based on time for a typical ISO 17025. If you're familiar with this standard, you will know that the time might not permit us to go in depth, and that's why it's an introduction. The purpose of this webinar is to introduce to each participant the concept of laboratory management system and how to initiate such based on ISO IEC 17025 2005. Basically, we are going to define what is ISO 17025 standard. Two, what are the benefits for test laboratory or calibration laboratory from ISO 17025? We are going to look at requirements for implementing the standard and implementation methodology. Okay. ISO IEC 17025. These are the basic requirements necessary for a laboratory to be able to implement and operate to demonstrate its competence. They are not super requirements. You hear a lot of people tell you that implement ISO 17025 is cumbersome, strenuous, but well, knowledge is power. So once you know what to do, it gets easier. There are still requirements. There are other ISO standards also, but there is need for proper understanding before embarking on ISO 17025. Why do we need this standard? Is it necessary for us at this point? What do we need to do so that we do not fall into the trap of endless audits and non-conformity? Costs. Cost of compliance and accreditation is the cost of achieving consistently good results. And the cost of not having consistently good results could be much higher. Now, the nature of the laboratory is you deal with data. You have to do with accuracy, precision. Actually, these are terms that would eventually define in the long run what is the difference between accuracy and precision. Because the work of a laboratory analyst, be it a chemical lab, a food laboratory, a mechanical lab, an electrical lab, is accuracy and precision. There has to be measurements that is internationally acceptable. So, what is the cost of not consistently achieving good results? These are the questions that ISO 17025 tries to answer. In the next slide, or next two slides, we'll look at the history of ISO 17025 and what led to that point where the standard was brought into bear. Because previous to that, we had 9001, which has to do with quality. ISO 17025 focus is basically on management requirements and technical requirements. If you're familiar with ISO 9001, then you are familiar with the management requirements aspects of ISO 17025. Actually, in the 90s, when the standard was being drafted from the ISO Guide 25, ISO 9001 was also under review. So there seemed to have been an intentional act to marry ISO 9001 with ISO 17025. The major difference being that the 9001 happens to now be the management requirements in 17025. And then the technical requirements now go into detail sampling, reporting, environmental conditions, and all of that. Now, history of ISO 17005. This is a lovely slide. The first publication of ISO 17025 was in 1999. You can see there. And then there was a second edition, or there is a second edition, which is the current one we are discussing, ISO 17025, which is 2005, which is the one in current use. And there's a review ongoing, but it's still being discussed. Now, prior to 1999, ISO 17025 was not in existence. But I mean, the other standards, the way standards, basically countries have their own standards on them for laboratories. But prior to that, we had ISO IEC Guide 25. It's very important. Actually, the first edition of ISO 17025 happens to be the revision of the third edition of ISO Guide 25. The first edition of ISO Guide 25 came to bear in the 80s, 1983, and they're based on good laboratory practice. So, merely looking at this slide, you can see the progression of how we got to where we are now from 1972, when there was a conference in New Zealand, and where New Zealand and Denmark introduced good laboratory practice documents, and then to the first GLP regulations in 1983, and then the EU, the European Council Directive on good laboratory practice in 1987. You can see the progression from country to continent and then international. There are other ISO laboratory related standards like 10,012, which deals with measurement processes and equipment. There's ISO 7218, which is microbiological examinations. There's ISO 18589 for measurement of radioactivity, and there's 15195 for laboratory medicine. All of them are, just related, but ISO 17025 broadly captures calibration and testing, and so most laboratories generally will fall at 25. All the requirements, if well implemented, will cover for most laboratories. Okay, I did say earlier in the slide before the last that ISO 17025 had been revised from 1999, and now we have for 2005. So why the revision? What has changed? Because if you see ISO IEC, something the major difference between 1999 and 2005 is emphasis on continual improvements. Emphasis similarity with, except for the technical, subsequently based on it's called the issue of continual improvement. All right. So insistence on the commitment to continually to communicate with the customers, and greater emphasis on the need to use information from quality control data to evaluate performance of the quality system and to identify opportunities for improvement. So in all of these, you keep seeing the word improvement, control data, quality management system, and if you marry the three, you will see that basically ISO 17025 focuses a lot on continual improvement. There has to be continual improvement on the system. Okay, the SHON words, or you can call them the TION words. There are three key terms that are very applicable in ISO 17025, and I intentionally put a slide because I noticed misuse of the term even by professionals. So you need to understand the difference between registration, accreditation, and certification. So registration is a procedure used to give written assurance that the system conforms to specified requirements. And in that regard, you could say a quality management system registration. Accreditation is a procedure by which an authoritative body gives formal recognition that a body or person is competent to carry out specific tasks. And you would normally hear ISO 17025 accreditation. You would not say ISO 17025 registration. You would say ISO 17025 accreditation, and then you would say quality management system registration. And then certification is a procedure used to provide written assurance that a product, process, service, or person's qualifications conform to specified requirements. I'm a certified ISO 17025 lead assessor, I've been certified by PECB. No, so I cannot say I've been accredited by PECB. Certification applies mostly to persons and products. The CE marking, for instance, is a certification. So you need to be able to differentiate between certification, accreditation, and registration. And I think I've used examples of the quality management system registration, the laboratory management system accreditation, and lead assessor certification to distinguish these three commonly confused terms. Okay, and this slide is mutual recognition agreement. Just some explanation there. In several countries, you find that you don't find ISO 17025 bodies or bodies that can accredit laboratories for ISO 17025. So, for instance, I'm in a country and I'm in country A, and we don't even have an accreditation body. I can apply to an accreditation body in another country, or we have an accreditation body in my country, but because of issues of recognition, they don't have international recognition yet, or they are still not at pace. They're not keeping to pace with renowned bodies. And I could apply to an accreditation body in country B, and then country A and country B signs a mutual recognition agreement, basically saying that we are country A, we have an accreditation body, but laboratory X wants ISO 17025 certification, accreditation, but they're applying to country B. So there's a mutual recognition agreement, so that if an accreditation body is coming in from another country, they are recognized in the country A, and then the certification and then the accreditation is recognizable. So a laboratory in country A and a laboratory in country B producing test results in country A and the other in country B have recognition of equivalence. And these accreditation bodies subject themselves to ISO 17011, which is the set of standards against which certification bodies are judged. Okay, good laboratory practice. The first or second slide, I think we talked about the history of ISO 17025, and at the heart of ISO 17025 is good laboratory practice. Actually, basically, it's not just about we have a saying in my workplace. If you put in data into an equipment, or you put in anything, you get something, right or wrong. There will always be data in the laboratory. But at the heart of it, good laboratory practice. And it extends beyond calibration. It extends to housekeeping. It extends to everything. And so the issues of conformity and compliance come in. And these are terms that are also generally confused. And so it's good to define them, understand the implication of non-conformity and how to distinguish non-conformity from non-compliance. At the heart of ISO 17025 implementation lies the commitment to good laboratory practice. Doing what you say you are doing and being able to prove it. That's conformance. Mostly during audits, what the auditor looks for, he doesn't come with some knowledge from some planet and ask irrelevant questions. He's basically trying to check what you say you do against what you actually do. And this lies at the heart of laboratory management. Doing what you say you are doing in your standard operating procedure, in your quality manual, in your work instructions, in your sampling procedures, doing what you say you do and being able to prove it. We do calibration regularly. Okay, can I see the equipment? I'm standing before the equipment. There is no calibration slip. There is no proof of calibration. I cannot look at the equipment and there is no record of who calibrated the equipment. There is no record of when the equipment was last calibrated. There is no record of when the equipment is due for a new calibration. There is no record for which parameter the equipment has been calibrated for. There is no record for the conditions under which the equipment was calibrated. Then I cannot say it's good laboratory practice whether the calibration is good or not. So non-conformance results in a written audit deficiency statement and requires corrective action. And then non-compliance, on the other hand, suggests fines or legal or regulatory action. So non-compliance basically has to do with legal requirements. For instance, when we begin to look at the structure of ISO 17025, you will see that under the management requirements, one of the first things you hear is the laboratory must be or shall be a legal entity. You need the permits, you need the certificates of operation. Without that, you are not a legal entity and you are not even recognized. So there are issues of non-compliance, there are issues of non-conformity. Non-conformance results in written audit deficiency, but non-compliance has some legal implications to it. And there are some thoughts here on laboratory best practice. In the previous slide, I said some things about this already. Does the laboratory say what they do? Three very important questions for every laboratory to answer. Does the laboratory say what they do? Does the laboratory do what they say? And can they prove it with their records? If you find yourself in an environment where laboratory management system is being implemented, you answer this question at the beginning. Do we answer these questions somewhere along the line? You will always answer these questions. You will never stop answering these questions. Does the laboratory say what they do? Do they have written documents? Do they have policies? Do they have procedures? Do they have arrangements that meet the requirements of ISO 17025? Does the laboratory do what they say? And ISO 17025. Note those two very important parts. The laboratory's quality system. Now, note I said earlier that ISO 17025 basically has to do with the management requirements and the technical requirements. The management requirements basically have to do with the quality system. So, does the laboratory comply with its own quality system and ISO 17025? And can they prove it with their records? Training records, standards preparation, work instructions, calibration certificates, everything. Customer complaints, feedback. The laboratory must show proof. Without proof, there is no evidence. And ISO 17025 thrives on objective evidence. There must be objective evidence. Okay, the relationship between ISO 17025 and 9001. You can see that the quality management system, the QMS, basically ISO 9001, and which is the management requirements. And then the other part of 17025 is technical requirements. So ISO 17025 covers technical competence requirements that are not covered in ISO 9001. That's the basic difference between both of them. Okay, now let's go to the structure of ISO 17025. I'll just give a rundown of the management requirements and a rundown of the technical requirements, and then subsequently we'll just we might not be able to pick every requirement in the in-depth because of time, but we have organization, management system, document control, review of requests, tenders and contracts, subcontracting of tests or calibrations, purchasing services and supplies, service to the customer, complaints, control of non-conforming testing work, improvements, corrective action and preventive action, control of records, internal audits, management reviews, and then you have the technical requirements, 10 items: general, personnel, accommodation, environmental conditions, test methods and method validation, equipment, measurement traceability, sampling, handling of test items, assuring the quality of test results, and reporting the results. It's important to also look at the process approach to quality or laboratory management system rather, and you'll find it called the PDCA. You'll find it called the Deming wheel or Deming cycle, whatever name you choose. The important thing is to understand how the process approach works. The basic process to laboratory management system implementation is plan, do, check, and act. You have to plan a quality management system. You have to establish a quality management system before you even begin to talk about accreditation for your laboratory management system. There has to be the planning phase where all the relevant questions must have been answered. Do we need this? Why do we have to do this? All those questions have to be answered, and then a quality management system must be established, your quality policy, your quality manual, and then you implement. The implementation phase is another phase that must be monitored and reviewed. As you implement your quality management system, you monitor and review it, and then you maintain and improve on it. This process is the same as the laboratory management system because they go hand in hand. Now, laboratory management system. The term management system in ISO 17025 means the quality, administrative, and technical systems that govern the operations of a laboratory. The management system includes organizational structure, policies, planning activities, responsibilities, practices, procedures, processes, and resources. There has to be a clear definition of who does what, who takes responsibility for test reports issued to the clients. Is it the laboratory manager? Is it the technical coordinator? There has to be clear definition. There has to be policies. There has to be an health and safety policy. There has to be a quality policy, which is very integral to the quality management system. There has to be procedures. You must have your standard operating procedures. You must have your working instructions. You must have your sampling procedure clearly written out and understood by every staff undergoing each of these activities. All of this put together is what constitutes the laboratory management system. Clearly written out, clearly spelled out, clearly understood, and carefully followed. The importance of laboratory quality. Laboratory quality basically entails accuracy, reliability, and timeliness of reported testing or calibration results. Let's take an instance. The laboratory has clients, and your client comes with jobs, and you tell your clients expected time of delivery is 10 days. Now there's a lot of effort put into the analysis, and the client calls back in 7 days and say, oh, good morning, Lab A. I just want to remind you that in 3 days I'll come over to collect my results. I say, oh, sorry. Oh, okay, that's true. Can you make it 5 days? Gradually, you're introducing breach of trust and contract. And then in 5 days, the client comes in, and oh, sorry, the lab manager is not around, and but we can assure you that we'll give you the best results. We're using the latest equipment, state of the art. We're using the best analysts. So don't worry, can you kindly come back in another 10 days? Now, how now do you define quality? The results are good, the timing is poor. So, in defining laboratory quality, we must look at accuracy, reliability, and timeliness of reported testing. And all of these are very integral to ISO 17025. Earlier, where we gave a rundown of the management and technical requirements, you could see aspects that had to do with the customer, with feedback, with complaints. There has to be a means to get feedback, there has to be a means to get complaints from customers. There has to be a means to continually improve on all of this. So, in defining quality, the laboratory operations must be reliable, tests and calibration results must be accurate, and reporting of the results must be timely. And so to differentiating accuracy from precision. This is just a chart to show that it makes it easier to understand, because generally you'll be told that precision is independent of accuracy, and accuracy is a measure of the nearness of the measured value to the actual value, and then precision is the measure of repeatability. So you look at the first diagram on the top left corner, you find it's not accurate, it's not precise. The green man is flying in another planet, while the other 3 guys are flying within the orbit. You find accurate are not precise. You find not accurate but precise, and then you find accurate and precise. So if you look at all the diagrams, for instance, the one that is not accurate but precise, they all seem to fall within the same cycle, but it doesn't make it accurate. It doesn't make it accurate. So this is just a brief explanation of the difference between accuracy and precision in the laboratory. Now let's go into the laboratory management system proper. And at this point, I would try as much as possible to give a rundown again of the requirements like we earlier discussed. In implementing a laboratory management system, both the management requirements and the technical requirements must be adhered to. And for the first one, like I said earlier, is 4.1. We call it 4.1 under the management requirements, which has to do with organization. And then we move on to the other ones. The lab shall be a legal entity. I had said that earlier about when I was talking about compliance. The lab shall be a legal entity. You must be able to identify potential conflict of interest and make sure that the staff is free of undue pressures. These are some salient elements of organization. There must be deputies for key managerial personnel. Like the example I gave earlier, the client comes in, oh, I want to get my test result. I say, oh, sorry, Mr. A has your result. He took it over the weekend, and then he'll be back on Thursday. Can you kindly come back in 4 days? No. there has to be deputies for each key managerial personnel so that there is continuity in the lab work. And then it takes us to the second one, which is the laboratory management system, clause 4.2, which you see right now on the screen. Now, for the laboratory management system, you must be able to define the scope, define a quality policy. Mind you, there are a lot of organizations where the laboratory is just a section, and such organizations actually could be certified to other standards if clearly define customer and other requirements of and very of control and procedures, communication, define responsibilities, and maintain integrity. Documentation. Under documentation, there has to be clear definition of the plan, the resources, the responsibilities, the priorities, the objectives must be put in place. Like I said earlier, let me take responsibilities for instance. From the point of sampling, the responsibility of the sampler must be clearly stated out, printed if necessary, and understood by the sampler, and documented to the point of sample collection, the chain of custody, to the point of analysis, to the part of quality control, to the point of issuing of the test results. Every step, every action must be, there have to be clearly defined working instructions that clearly states ISO 17025 does not give the luxury for assumptions. There has to be clear definition of every step that's needed, and there must be control and communication, set training in place, an awareness program. Actually, it's very key that at the start of LMS, there must be training for everybody involved. Actually, it's advisable to train every single person involved in the chain from sampling to issuing of results, and then maintain integrity. Documentation control or document control is clause 4.3, and it's very important to also note this. These are some of the key documents in ISO 17025: policies and objectives, procedures and controls, test and calibration methods, laws and regulations, quality manuals. The laboratory shall include documented systems of a quality policy and quality objectives, a quality manual, documented procedures and records required by the standard, and documents, including records determined by the organization to be necessary to ensure effective planning, operation, and control of its processes. Document changes. All changes should be documented. Date of issue, revision, identification, and everything. And this also takes us to review of requests, tenders, and contracts, which is another clause. Responsibility for work performed by subcontractors. There must be a record of review. Differences with contractors or tenders must be resolved before work commences. And I would like to talk about service to the customer. I think this is very key to ISO 17025, just like the other clauses. The lab shall allow customers cooperation in clarifying requirements and monitoring performance of the laboratory. ISO 17025 makes it very clear that the lab shall seek feedback, positive and negative, from its customers, and feedback shall be analyzed to improve the management system. And another clause, which is 4.8, is policy, is complaints. The lab should keep records of complaints, including all investigations and corrective actions. Clause 4.9, control of non-conforming testing and calibration work. Basically here, the lab shall find the root cause of all non-conforming work produced by the laboratory. And 4.10, which I talked about earlier, is continual improvement. The lab shall continually improve the effectiveness of the management system. The quality policy must be committed to this. The quality objectives must be committed to this. The audit results must be followed up. Analysis of data, corrective and preventive actions, and management reviews. All of these exercises put together ensures there is continual improvement in the laboratory work. To briefly look at the technical requirements before I go to the next slide. I talked earlier about the personnel, and basically here, the laboratory shall identify training needs and provide training. The nature of training actually is key to understand both the managerial competency of personnel. There must be appropriate supervision. Under accommodation and environmental conditions. At what temperature are you taking documentation already, the manuals, procedures, the effectiveness of its management system. Okay, I'll give a this which the input elements include look at to conduct internal audits. Look at the audits, and then look at corrective and consider reports from managerial and supervisory personnel. Management must look at customer feedback and complaints and recommendation for improvement. There can be no effective laboratory management system without management commitment. The management has to be committed to putting in these input elements to improve the management system. Committee assessment approach. Before I take this slide, earlier I was talking about the technical requirements. I'll briefly look at some of the technical requirements before returning to the slides. I talked about accommodation already and personnel training. Test and calibration methods is also very important. Appropriate methods must be used for testing. Under this category, we have standard methods and then non-standard methods. We also have laboratory developed methods. But the important thing is use methods that are appropriate to the tests. Non-standard methods shall be agreed with the customer. The customer must know, I'm using an if I'm not using an AST method, I'm not using a USEPA method. I'm using a method that has been developed in my laboratory. Has the method been validated? And does the customer understand and commit to the use of that method? So there must be proper communication of test methods with the client, and it must be agreed. As much as possible, it's advised to use appropriate test methods, mostly standard methods. And in cases where non-standard methods are not used, those methods must be validated. There has to be validation before you use these methods in the laboratory. There is also estimation of uncertainty, also related to test and calibration methods. Basically, there are two ways of estimating uncertainty. Statistical analysis, for instance. Let's say we have repeatability, and we want to estimate it. A good way to do that is standard deviation of a set of repeated measurements. So there are ways to estimate uncertainty. Other means including finding the uncertainty in calibration results, for instance, on the calibration certificate, or ascertaining the value of a reference material from the material certification. So all of this must be strictly followed in implementing ISO 17025. Equipment, that's clause 5.5. The equipment in use. Calibrate equipment when due, and keep record of calibration. I'll just take this item very briefly. I talked earlier about the calibration slip, and then also calibration certificate. If an auditor comes to a laboratory and there is this gigantic state-of-the-art equipment, and he says, okay, can I see proof of calibration? And so the very proud and enthusiastic and accomplished analyst goes over and then puts on the monitor, and he says, oh, behold, this is my calibration. Of course not. The auditor wants to see, when was it calibrated? That should be the Thursday before the last. No, there has to be proof. Equipment will be calibrated, and there has to be proof of calibration. So the asset number, that's to identify uniquely that equipment, and enter the equipment is calibrated for. You see the name of the calibration date. That is object. Should be attested to by either the laboratory manager which is measurement traceability. Where samples are taken. It's very important. And deviations from management and the clients. Abnormality, and it's advisable receipt, handling protection, the quality of test results is reporting the results. I'll take some time on that to for reporting results in ISO 17025. And if you state the title, there should be a name. There there should be serial number or unique identification. There should be client identification in detail. For instance, sample numbers. There should be the date of reception of the item and date of testing. Your report should also carry identification of the method used. You are using an ASTM method, you are using an US EPA method. There should be a note of any deviations from a standard. There should also be the results parts, which will carry the units. It's also advisable that there should be the name, position, and signature of the person accepting responsibility for the report. Very important. In some cases, you find the lab manager or technical coordinator appending his or her signature to every page of the result. If it's possible, there should be the date of issue of the report, and the test report should also carry, preferably, a statement that the result shall not be reproduced without the written permission of the laboratory. And there should be uncertainty of measurement. This is compulsory in calibration reports, and evidence of traceability. So basically, this gives an idea of the clauses, clause by clause, involved in ISO 17025. I talked earlier about the management requirements, and I just talked about the technical requirements. So you can see that we have 15 management requirements and 10 technical requirements. And for you to be ISO 17025 compliant, you must follow clause by clause. The implementation of elements has to be clause by clause. You cannot say, oh, we followed every requirement, but we did not give room for customer complaints or feedback. It's a non-conformance. So every clause, the 15 clauses in the management requirements and the 10 clauses in the technical requirements must be followed duly in implementing laboratory management system. There are different approaches to 17025. Traditionally, the popular approach is sequential, where you have a plan, develop your policies, you begin to effect or implement management system, and side by side you implement control and then management review. But there's a disadvantage with this, being that the process takes time, it becomes cumbersome, and at some point there might be lots of interest, such that you begin the process of implementing ISO 17025, but you never complete it because of time. And so there are different approaches that are coming up rather than the traditional sequential approach. For instance, the business approach, there is a systems approach, there is a systematic approach, there is an integrated approach, and there is also an iterative approach. For instance, looking at the business approach, you can integrate into the context of commercial activities across the organization. Like I said earlier, you find organizations already certified to 9001 to actually integrate into the context of commercial activities across the organization. And the integrate because integrating the LMS to harmonize it with other ISO 17025, which has ISO there are some organizations that are already not on in some cases, if such but when the laboratory wants to do and in that case regulatory bodies and then how to manage this cycle is on or every individual implementing ISO under the plan. We've talked about almost most of these already. Initiating the organization, analyze the existing system, and the policy. These are basically things you do before you implement your management system. And then do organizational management. These are very broad topics. We talked about documentation already, a clause. Communication, training, management, customer management, operation management. These are the things you do. And so what do you check? You monitor, you measure, you analyze, and you evaluate continually throughout the life cycle of implementation of management system. And then there has to be an internal audit. Management has to act on the reports of the internal audit to ensure continual improvement via treatment of non-conformities. And this brings us to the last slide, which is a typical schedule to develop an implementation plan. The first 2 months can be for training, defining the occupational health and safety management system, conducting your gap analysis, and planning. That's plan. So it depends. It depends on how fast the organization is. If you are very new to ISO 17025, it might take you some time to plan it out, and that's why it's good for avenues like this where people get trained. And it's not difficult. It's just understanding. Once there's knowledge, it becomes easier. Like I said earlier, ISO 17025 is not. There are no super requirements. They're just requirements that need to be understood, both on the part of management and technically. So in 3 to 4 months, you should be able to establish practices and documentation, and then select a certification body in country or outside the country, and then implementation stage. There is no hard and fast rule that says that within the first 2 months you are not implementing anything. No, it's interwoven. But in 5 to 6 months, implementation should continue, operation, and evidence. These are the things that your auditor will look for when they come for audits. So in 7 to 8 months, it should be good for pre-assessment, internal audits, management review, and corrective action. Now, if you notice in the first 2 months, there should have been training. In the process of training, some members of staff could be trained as internal auditors. So in 7 to 8 months, when you are ready for your pre-assessment audits, internal auditors within the company can now come into play and then pass the results of the audits to the management, who will review and implement corrective actions. And all of this is documented. There has to be objective evidence that every non-conformity, there is a root cause analysis. There has to be objective evidence that for every non-conformity, corrective and preventive actions have been implemented. And in 9 to 10 months, your certification body will be ready for both stages of audits and corrective actions, if necessary, and certification, if required. And then subsequently, there will be audits, follow-up, and surveillance audits. As time goes on, surveillance audits will not necessarily have to be very frequent. So basically, this is the rundown of ISO 17025. It's interesting. I would say I work in an environment where ISO 17025 is being implemented, 9001 is being implemented, 14001 is being implemented, 18001 is being implemented, and the concept of implementation of ISO, apart from work, is also life transforming, because it teaches you, it helps you to understand how to run a laboratory according to international standards. Before I round up my webinar, I would also like to state that one very core aspect of ISO 17025 is proficiency testing. We did not have all the time to talk about every item by one. The laboratory should be able to submit itself to proficiency testing. This is part of the way to assure quality of testing results. And that's actually a clause under the technical requirements, clause 5.9, assuring the quality of test results. Proficiency testing should be part of the laboratory management system implementation. And once all of this is done, audit is done, internal audit is done, corrective actions are taken, certification is issued, continual improvements, and then the laboratory sees the results of the management system. Thank you very much for this 1 hour webinar. It's 1 hour already. Thank you for joining me. I'm glad.